Excuse me. All right, so the volume of this, the overall volume of this would be equal to those three things multiplied together. Now, this gives you the volume capacity of everything on the inside. So you've got your x, x minus 1, and x plus 9. Now, the volume on the whole inside chunk is like the holding capacity. That's what they're talking about, that 500 gallons. How much crap can you put in that steel prism thing? So that's the 66.85. Now, where they're coming with this whole thing of the thickness of the metal, they say that if steel that is 1/2 inch thick is used for the walls of the tank, then about 5.15 cubic feet of steel is needed. The manufacturer wants to know the outside dimensions of the tank to be related as follows. What should the outside of the dimensions of the tank be? Well, this gives you, that's the stuff on the inside. Then you have to worry about that, the outer portion. So you're adding in that extra thickness. Does that make sense? You've got your walls that are built up, but then the thickness is added to it. So you add to that 5.15. So that gives you what, 72? So it winds up giving you a somewhat clean of a number then. On this side, oh, Devin's not here today. He's got a field trip. Thanks for asking. So on the other one, you FOIL it out, and then you just multiply everything by an x. So it works out pretty quick. You get x squared minus, x squared plus 8x minus 9. And to that, you would distribute an extra value of x. So you wind up with, move this up, x cubed plus 8x squared minus 9x minus 72 is 0. And you could probably see right now that it works itself out to being a fairly clean factor by grouping. Okay? So if you factor this by grouping, we're looking at our GCFs. GCF here gets me an x squared. Then I'm left with an x plus 8. On the next one, always remember my trick. Make the negative 9, so that way you remember that you have to take the negative 9 out. And then we get an x plus 8. Now, some of you guys have been asking throughout the day today, when you get to this point, it doesn't matter what your degrees and all that stuff are. As you factor by grouping, if your things that are in the parentheses are the same, you're on the right track. So you write them down. X plus 8, and then the other term would have been x squared minus 9. Since we have this equal to 0, I can do one of two things. I can set them both equal to 0, solve for x, or if I want to be rambunctious, I can factor out the x squared minus 9 a little bit further if I want to do that as well. It doesn't matter. If I get to this point, normally what I would do, knowing that it's equal to 0, I would just get my zeros and just write it down. My zeros are at negative 8 and plus or minus 3. Now, think about what your dimensions of the tank were. The dimensions of the tank were x minus 4, x minus, and x plus 9. Of those values, only one of them works. Positive 3. Positive 3 is the only value that's going to give you something that works. So your thickness of the value of x has to be 3. And I think in that case, that meant the length was 3, because everything else was built off of length, I believe. So if our length was 3, and then you'd have, the other one would have been 2, and the other one would have been 12. And there's your result. Okay? Does that help on that one? Now, 87 it's exactly the same thing. They're just not telling you what the x and the x minus 1, the x minus 9, or x plus 9 were to begin with. In 87, you have to come up with the actual portions of it. Oops. I did not have this open. I didn't. On 87, they said that It needs a box to have a volume of 30 cubic inches. The width is 2 inches less than the height, and the length should be 5 inches greater than the height. What are the dimensions? Okay. So remember, you're talking about the box. You have a length, width, and a height, and in this case, it has to equal 30. So what does the word "is" mean in math? Equals. Width is 2 inches less than the height. Height minus 2. Length is 5 inches greater than the height. So in this case, what are we going to solve it in terms of? H. We're going to solve it in terms of H. So you would use it winds up being the exact same problem. You wind up with H minus 2, H plus 5 is 30. Distribute and go. And I think this one wasn't as clean of a number. I think your roots were plus minus root 10.
Yes.
Yeah, so your H value want to be like the square root of 10, so it was some decimal like 3.3 or whatever, or 3.2 or something like that. Okay. But if you do basically the exact same thing. Okay. What else you got on that one from those book pages? Anything else? Which one? 82? Sure. I'll get you next. What is your first rule of factoring? Take out your greatest common factor. All right, well, in this case, we wind up with 4x to the 4th plus 20x squared plus 25 is 0. In this case, I do not have a GCF. I don't have a GCF, so what I have to do is I have to factor this one the exact same way that I would any other regular boring trinomial. I multiply my tails together. So I take what is 4 times 25? 100. What times what is 100 that I add together to get 20? 10 and 10? 4x to the 4th, 10x squared, 10x squared. And this actually is jump squared. You could have done it that way too if you recognize the pattern. And then you just go via GCFs here. If I go GCFs, I get 2x squared. I'm left with 2x squared plus, what was that, 5? And then on the other one, I take out a 5, and I have a 2x squared plus 5. Then you get 2x squared plus 5, and a 2x squared. Now, this problem will not give me any real solutions. Okay? I will have no real solutions for this one because if I subtract 5 divided by 2 and take the square root, I'm going to have imaginary. So this one would give you no real solutions. But if I ask for all real, or excuse me, if I ask you guys to give me all solutions, remember, all you have to do that is this. Divide out by the 2, take the square root. Now, when you take the square root of a negative, what automatically happens? You get an I, and we have a plus minus. So think of this as plus or minus I, but then I have the square root of 5 divided by the square root of 2. How do I undo that? Yeah, multiply by the root 2's. So you're multiplying by a conjugate is technically what you're doing. So this becomes plus or minus I root 10 over 2. And you wind up with 2 sets of them, since it's the same 0. But you only have to write it out once. That would be your all zeros solution. And that's what that would look like. As opposed to some of the other ones where you have some real and some imaginary and whatnot. There's a big difference between one like this and what was the one on the worksheet? Was that the x to the 8th that I was working with you? What number was that? 19? I'm going to go back to that one there in a second. But anything left on the book page before I go to the worksheet stuff? Somebody else had. Yeah, one last one on the book then. We'll switch over to that. Which one do you got? 80? 12 I think is a little bit easier. When I'm looking at 11, you automatically think to yourself, all right, GCF, oh, it's got to be 54. No, it doesn't work that way. What you can take out of here is just a 2. Okay? You get 64 x cubed plus 27. Now, is 64 a perfect cube? Yeah, it's what? 4. It's 4. So this is technically 4x cubed plus 3 cubed. So when you're using that special pattern, you have to remember to square the 4 as well. So it's not just going to be 4x squared, it'll be 16x squared. Silly mistake that happens all the time. So if I factor this completely, I'm going to get 4x plus 3 times the quantity. 4x quantity squared, 16x squared. 3 times 4 is minus 12x plus. And that would be factored fully, because you cannot factor that second trinomial piece without, falling into a vortex of death. Yes, sir. And we wrote it down from the 6-4. So one thing we learned, just one new thing. Factor the a squared. You got it. I was going to say, otherwise pull it up. It's on the very first page of the 6.4 out of the book. Going on from there. Whenever you have trinomials with higher degree exponents, as the exponents start at a 4, the next one's a square, and then you have nothing else, treat it the exact same way that you would any other regular trinomial. X squared, x constant. So you would treat both of those the same way. Same thing as you got to, and I'm just going to skip ahead a little bit here. If I get to one like number 17, number 17 and number 18 are very, very similar to each other. And I'll go back to 15 and 16 in a second. Actually, I think those two are a lot easier than this one. When I'm going to this, think of it this way. What times what gives you x to the 8th that are both the same? X to the 4th. So when you're thinking about it, when you're taking a square root, when you're thinking about perfect squares, a square root is technically half an exponent. So if it was x to the 8th and I took half of it, it would be x to the 4th. So this becomes what times what 16 that you got together get negative 17. Negative 16, negative 1. So you get x to the 4th minus 16. X to the 4th minus 1. Is x to the 4th a perfect square? Is 16 a perfect square? Is that a subtraction symbol?
Yes.
Is x to the 4th a perfect square? Is 1 a perfect square? Is that a subtraction symbol? So you get difference of squares twice. X squared minus, oh no, I got it again. Oh no, I have it again. Now, what's nice here is that it's asking for your zeros. So technically, you do not need to factor it. Oh, was it factoring? Oh, usually when it has zeros, when it equals 0, I'm just going to say find all the zeros. Okay. Usually, hey guys, this is a good point here. If it says factor, you're not going to see equals 0. That's normally how I write it. But if it says find all zeros, I'll definitely have an equal sign in it. So if it said factor, then you would do this and write x minus 2, x plus 2, and then go on the rest of the way and factor the x squared minus 1. Since I have it equal to 0, at this point I can stop my factoring because here I can just write out all my zeros. I know that I have zeros at plus or minus 2. Here I'm going to have zeros at plus or minus 2i. Here I have plus or minus 1, and here I have plus or minus I. So I have an 8th degree polynomial. Remember, if subtract 1, take the square root, what's the square root of negative 1? I. Square root of negative 1 is I. Just like I had, what's the square root of negative 4? 2i. So I have an 8th degree polynomial that has 2, 4, 6, 8 possible zeros. Just so happens that half of them are imaginary. This is something that you can't graph, but I can list all my zeros. Okay. Something you can't graph, but you can list all your zeros. You can tell me where the tails are going. Where the tails going in this one? It's good. Okay. Number 8 is basically the exact same problem, but I think it has 25 and 1. So we have plus 5s and plus 1s. So. 15 and 16. If I'm not mistaken, both of those guys go GCFs. Okay. I think on 15 you get an extra set. So if I look at I know this seems so far along ago. Okay? It seems so far long ago, but if you think about it, you've been doing that with working with your exponents throughout the other three sections. So when you're working with your exponent rules, you kind of have to remember some of the rules. For example, when you have junk to an exponent, what do you do with that exponent to the pieces in the junk? Yeah, you kind of distribute through. What do you do when you have power to power? You multiply, good. So this example here would give me 2 cubed, which I'm just going to write. It's going to be 8 x to the 6th 5 times 2 x cubed. Here's a 15. Where does that x to the negative 2 go then? Goes to the bottom. So now you can go ahead and start simplifying stuff out. As you simplify stuff out, it's always easier to start with your numbers. Well, 4 times 3 is, this becomes x to the 5th. X to the 6th over x to the 5th, who wins? So, 12x. And there's your answer.
Oh, I got it.
I made this guy's unhappy, so he moved down. And I just simplified this. 5 goes into 15 3 times. 2 goes into 8 4 times. 4 times 3 is 12.
That's incorrect.
2 cubed. It's not 15. What's 15 divided by 5? I just simplified a fraction. It's not to the third. I simplified a fraction. You guys, there's this little thing called simplifying that I've learned over the course of years that students seem to have forgotten. These were the numbers that were in there. 5 goes into 15 3 times. 2 goes into 8 4 times. 4 times 3 is 12. I've been simplifying the fraction. It's one of those things that it's a lost art. You guys don't know how to simplify fractions. It is. What part were you get lost on? X to the 6th came from x squared cubed. That's power to power, you multiply. X to the 6th, this over here was x to the 5th. 6 is bigger than 5, so 6 minus 5 is 1. You remember you played war? Same base, different exponents when you fight. No, power to power is when you multiply. I just distribute. I distribute. Then I add. No, it's not. Power to power. Yeah, synthetic substitution is a thing. That was one of the, I was in 6.2, I believe. Synthetic substitution is kind of what I was trying to do over there, where you work your way through.
Yeah, so that's when you have like that. Yeah.
I recommend run through those review problems that are on that PDF file. Stop by in the morning, see if you got a question. Well, let me stop.